So again, case 3. So in case 3, problem number 3, 5 masses m1, m2, m3, m4, m5 revolve in the same plane. Means this is the third case. You can get this from, so this is the third case. That is, there are several masses in one plane or same plane. So this is the third case. So magnitudes of m1, m2, m3 are 5, 2.5 and 4 kg respectively. The angular positions of m2, m3, m4 and m5 are 60 degrees, 135 degrees, 210 degrees and 270 degrees from mass m1. Determine the masses m4 and m5. So here we can look that, we can check that. So radiuses are not given here. So any of the radiuses are not given. If any of the radiuses are not given, so assume all the radius as one unity. So r1 equals to r2 equals to r3 equals to r4 equals to r5 equals to r, or just r equals to 1. You can take it as unity. Now this is the space diagram. So as we know that mass 1, all the other masses are with respect to mass 1, means mass 1 is at horizontal or 0 degrees. So mass 1 is at 0 degrees or horizontal. Mass 2 is at 60 degrees given. Mass 3 from mass 1 is 135 degrees. Mass 4 from mass 1 is 210 degrees. And lastly mass 5 from mass 1 is 270 degrees. So this is how we draw the space diagram. Now draw the tabular column. So name it as mass, radius and force. So mass m1 is 5, m2 2.5, m3 4, m4 and m5 are unknown, which you have to find. And radiuses are r means we will take it as 1, r equals to 1. So multiplying both, or r equals to 1, we will take it as r equals to 1. So 5 into 1 is 5. 2.5 into 1 is 2.5. 4 into 1 is 4. m4 into 1 is m4. m5 into 1 is m5. So taking r is equals to 1, naming all r as unity 1. Multiplying both, we have same as mass. Now we will directly solve graphically and get the answers of m4 and m5. So we will try to solve this directly graphically. So as we know, so masses are given, r radius we will take all the radius as one unity. 5 into 1 is 5, 2.5 into 1 is 2.5, 4 into 1 is 4, m4 into m1 is m4, m5 into m1 is m5. So this is a space diagram of all the angles shown. Now we'll draw. So using this force, using this column, we will draw the force polygon. Before that, depending on these three values 5, 2.5 and 4, we'll take a scale. Since this 5, 2.5 and 4 are drawable, so we can take the scale as 1:1, means 5 means 5 centimeter, 2.5 means 2.5 centimeter, 4 means 4 centimeter. So we will one by one we will. So first comes m1, mass m1. First comes mass m1, 5. At an angle, m1 angle is 0 degrees. So at 0 degrees or horizontal, so draw a angle from O to A 5 centimeter. Draw O to A 5 centimeter till A. Now take the second mass m2, 2.5 at an angle 60 degrees. So this angle 60 degrees. So from with respect to horizontal, with the taking angle 60 degrees, draw 2.5 centimeter. Draw 2.5 centimeter till from A to B. Now again at point B, draw a horizontal line. Draw a horizontal line just for the angle reference. And also all angles should be in the counterclockwise way. Should be calculated counterclockwise way. So again from point B, draw a horizontal line. Take an angle of take angle for the third mass, there is M3, which is at 135. So take an angle of 135 degrees from point B with mass M3 as 4 means 4 centimeter with the scale. So draw a line with 35 degrees from B to C 4 centimeter. This is point C, 4 centimeter. Now other two masses M4 and M5 are unknown, but we know the angles. One it is at angle 210, M4 is at 210, M5 is at 270 degrees. So first we will, since we have to close the polygon to balance the system, so first we will draw the angular direction of M4 mass. So my M4 mass is at 210 degrees from point C. With respect to horizontal, we'll draw a 210 degrees, means opposite, taking the opposite of the productor, means from here we should draw over 30 degrees and draw a line M4 and just extend it. We don't know the value of this, just extend it below. Now from point O, now since you have to close it till point O, now from point O draw a line 270 degrees, means with respect to horizontal measure 270, which is below. Instead of driving below, just extend it upwards, show the arrow downwards. So we intersect at point D. So this line and this line intersects at point D. So this point D intersects M4 and M5 line. Now we can measure the M4 and M5 to get the masses. So measuring the line M4 and that is the line CD and DO, we get the masses. So from the CD into scale is 1 is equals to M4. 4 into 1 is for mass M4 is 4 kg itself. OD into scale is M5, that is OD is 3 centimeter into 1, that is M5. So therefore M5 equals to 3 kgs. So this were to find the masses of orthogonal masses.